Okay, so on this question, we have this natural log, which is just a special kind of log, and it follows all the same log rules of this big old expression, and they want us to break it into 3 natural logs and identify what A, B, and C are. Okay, so how do we do it? Well, we're going to use the 3 log properties. Here they are. So the 3 log properties basically say 1 log becomes 2 when multiplying becomes adding. And 1 log becomes 2 when dividing becomes subtraction. So basically, easier operation for 2 logs. So see how we have the harder operations of multiplying, dividing, right? Multiplying, dividing are higher level operations than adding, subtracting, which are easier, right? So it's a harder operation for 1 log. It's easier for 2. Okay, and not only that, also we got the square root thing. Yeah, let me handle the square root thing. What do we know is true? Well, basically, a square root can become a fractional power. How so? Whatever's in the hook, you can swing that around and make that into the denominator of the fractional power, and then the root vanishes when you do that. You can turn a root into a fractional power. Now, the trick is, what do you do when you look at a root that has nothing in the hook and no power? Well, that means it's half. Why? Why does that mean it's half? Because really there's an invisible 1 power here. You know that, right? And there's a 2 in the hook. And so that 2, you see, swings back around and goes to the denominator. So if there's nothing showing on the root, if there's no power showing, then we always know that means a 1 power. And if there's nothing in the hook, this might be news to you, it's a 2. It's a square root. Square means 2, huh? So if there's nothing in the hook, we call it a square root. And what does square mean? 2, right? This is called what? X squared. Square means 2. So square root means 2 root. So if there's nothing in the hook, it's really a 2. It's a square root. It's a 2 root. And that 2 swings around and becomes the denominator fractional power. Okay, well, that's what we have going on here. Whoops, here we go. See this root right here? There's nothing in the hook, which means what? There's really a 2. And yeah, but there's no power on anything. Right, so that means really there's 2 here, and this is all 1 power. So what this means is this is ln of x to the 8 times x minus 1 to the half power all over 3x minus 1. I'm not done yet, but I just got rid of the root. Does everybody see that? Whenever you have the root on something, whether it be 1 item or 2 or 10, it just means that whole chunk to the half power with no more root. A root means a fractional power. And if there's nothing in the hook, it's a half power. Everybody see that? Because it's a square root. It's a 2 root. No more root, right? That's what this is saying right here. If you have a root, this is invisible and this is invisible, it's a half power. Nothing in the hook, it's a 2. All right, okay, so what now? So now we can break that into 3 logs. We can say, oh, this is ln of x, and then this times right here is going to become plus. And then the next log, ln of x minus 1 to the half. And then this dividing bar is going to become subtraction. ln of 3x minus 9. Oops. So that makes sense. And by the way, you do need to have parentheses when you have more than 1 item added or subtracted plugged into a log. More than 1 item in a log. So yeah, this just has an x to the 8. That's just one thing to the 8th power. So you can put parentheses if you want to, but it's not needed. But here you've got to have these parentheses. Why? Because, well, we don't care in the end because they're not even going to ask. All right, I'll skip it, but let's keep going. All right, so now I'm going to take that one more step, and now it's log property 3. which says when you have one log with a power, you can bring that power down to the front of that one log. So whenever you have a power on one log, on an item in one log, you can multiply it, bring it down to the front. That's log property 3. So I'm going to do that now. So this 8th power right here, drop down to the front. So it's going to be 8 ln x. And then this half power, drop down the front, plus a half ln x. And now what's, oh, what, did I lose a half power? I did. You guys got to tell me when I do crazy things like that. Over here, I forgot the half power, didn't I? Oh, no, wait. No, there's no power there. I am totally confused. There's no power there. There never was. So that one's just minus ln. That one didn't change, right? Okay, so let's identify our A, our B, and our C. So A is 8. That's easy. B is a half. That's easy. Now, what is C? What number is in front right here of this natural log? There's no number there. What does that always mean? Could I put like a 7 there? No, because that's different. 7 times natural log is totally different. But what number could I put a 0? No. 0 times the natural log would make the whole thing 0. That certainly changes it. It's a 1. Because 1 times it doesn't change anything, does it? You see why we put 1? Because it doesn't change anything. It's the same thing as if a 1's really there. But it's a minus 1. Watch out. Everybody see it's a minus. Now, where'd that minus come from? Well, it came back over here because it was divided. Remember, anything divided, you're dividing by the 3x minus 9, that log is subtracted. Anything times, that one's added. Remember, that's what the log property said. Multiplying becomes adding, dividing becomes subtraction, right? So that item was divided, which became subtraction. So down here, it's a -1. And so there we go.